back to another week of geometry. The new material for this week is going to be sections 12.3 and 12.4. It is a bit trickier than last week's stuff, and we'll have to review some things that we covered in chapter 10 that you haven't seen in a while, but that'll be good practice for the final anyway. So let's get started. Okay, let's jump right in. I want everyone to open your books to page 780, and this is the new section, and we're going to be studying inscribed angles. Okay, before I want to talk about those, I want to do some review. First of all, notice the word in is actually the same word as inside, so remember that, but let's go back to something earlier. So I want you to flip your book back to, tangled up with the tripod here. Open your book and flip it back to page 649. Okay, and we're going to do some review. First of all, a circle, duh. It's a group of points that are equal distance from a single point. And that's why, and everything inside the circle is going to be the radius. Okay, we know what a diameter is. I want to talk about the concept of central angle. An angle is a central angle if its vertex is the center of the circle and the two sides of the angle are the radiuses, or radii, I guess you would say. So that's a central angle. And then, so that's the starting point. Make sure you know what a central angle is. A central angle, the vertex is the center of the circle, and the sides of the angle end up being two radiuses. Okay? Now I want to remind you of something we learned a little bit later, and that's the concept of an arc. So if this is the central angle, then this red line here is the intercepted arc. And the formula that we've learned in the past is the measure of the arc, the degrees of the arc, not how long it is, but how much of the circle it's opened, is the same as the central angle. So if the central angle is 45, the arc is 45. For this one, they want to know this arc, and we know this semicircle is 180. This part of the arc is 60, so this is 120. So this central angle would be 120. This central angle would be 60. So that's what a central angle is, but we haven't done it in a while, so I wanted to review that. And now we're going to go back to page 780. So return your book to page 780, and we're going to talk about inscribed angles. There's going to be a lot of different angles before we're done, so we want to make for sure we have this one down. Okay? So first of all, an inscribed angle is an angle where the vertex is on the inner part of the circle and the two sides of the angle are chords. Remember, a chord is just any line that starts on one side of the circle, goes to the other side, and covers all interior points of the circle. So AB is a chord, BC is a chord. So angle ABC is going to be an inscribed angle. Now, we always had a big rule that you couldn't name an angle with just one letter if there were more points coming to it. But since this is an arc and this is an arc, we can still call this angle B because the only straight lines coming into it are this one and this one. So we don't have to call it ABC. We can only have to call it angle B. And here's the formula that you need to know for inscribed angles. So if you have your book, I want you to actually write this in your book. I want you to write inscribed angle right there, because I want you to remember that it's only a formula for inscribed angle. So the inscribed angle is half the measure of the, and under AC I want you to write intercepted arc. And if you had a book from one of my earlier classes, it will already have those things written on it, okay? So that's the inscribed angle theorem, and it's going to become useful later. Okay. And this up here is just a proof. We're not going to mess with that. So we're going to go ahead and jump straight into the got it problems. So we'll do got it problem A first. So everybody needs to be on the bottom of page 781 and look at got it problem A. I'm going to move this out of the way so I can do my work. First of all, you don't always have to draw a circle, but I'm going to because I think it's a good habit to be into. So we have this circle, and we have this chord, and I actually didn't draw that very well, so I'm going to draw it again. because the chord is actually a diameter, so it's passing through the center of the circle. Okay, and we need to be able to calculate angle A. The reason we only have to call it angle A is there's just two straight lines coming into it. The curves don't matter. So first of all, recognize that that's a diameter, which means that arc is 180 degrees, and you have to recognize that angle A is what kind of an angle. I'm going to let you try and say it before I say it. Hopefully you said inscribed angle, so we know that the measure of an inscribed angle equal 1/2 the measure of the intercepted arc. So we know that angle A equal 1/2 of 180 degrees. So, measure of angle A. So we know the measure of angle A is 90 degrees. Easy peasy. Okay, let's see how we can apply that to something in the future. So now I want you to look at problem B. What are the measures of A, B, C, and D? Okay, I'm going to draw this one too. A, B, C, and D. Notice it's a quadrilateral, but we don't know anything else about it. So mine kind of looks like a rectangle, but it's not supposed to. So kind of go bore. And then we know all of the intercepted arcs, which is kind of nice. Tracing intercepted arc on inscribed angles is a little trickier. So first of all, I'll start with measure of angle A. And you're going to trace it out to there and out to there. So the way you find out what the intercepted arc is for any given inscribed angle is you have to trace both sides of the angle. So I know the measure of angle A is going to be 1/2. And then we know it's going to be intercepted arc BCD, 100 degrees plus 90 degrees. So the measure of angle A is going to be 95 degrees. Okay, let's scoot this over so we have more room. Okay, now we're going to do the same thing for angle B. The measure of angle B is going to be 1/2 the intercepted arc. And you'll notice this goes to here and here. So the intercepted arc is going to be arc CDA. Okay, so the measure of angle B is going to be 1/2 CDA, 90 plus 64, that's 154 degrees. Measure of angle B is going to be 77 degrees. And then you'll do the same thing for the other two. So we'll do angle C. So I'm going to put my thumb there, trace it to there, and trace it to there. So I know the measure of angle C is going to be BAD. I kind of like that. 1/2 of the intercepted arc BAD. And remember, the way you write that, M means measure, which tells you it's going to be degrees. You write however many points you need, and you put the curve over it. So the measure of angle C is going to be 1/2. BAD is 106 plus 64. I'll have to do that on the side because I didn't do that in advance. 106 plus 64. Duh, I should have been able to do that in my head. 170 degrees. So the measure of angle C is going to be 85 degrees. And that's how you do those. Let me double check and make sure that was right. I'm not on the right page. I'm pretty sure it is. Okay? So that's how you handle those. Okay? Because of those rules, there's going to be a couple corollaries. So let's take a quick look at those. All of that allows us to prove that if two inscribed angles intercept the same arc, then they're going to be congruent. Because if you'll notice, this one intersects this blue arc, and angle B also intersects the blue arc. So they're going to be congruent to each other by transitive property. This one is even more obvious. If the inscribed angle connects to a diameter on both sides, then it's got to be a right angle. And that's because if it's inscribing a semicircle, the semicircle is 180, then the inscribed angle is half of that, so it's going to be 90. Corollary 3 just says that if you draw a quadrilateral inscribed inside of a circle, then the opposite sides of the quadrilateral will always be supplementary. And we won't really need that. We'll end up proving it later. Not proving it with the proof, but just showing it. So let's go ahead and work one of these problems. Actually, we just did one. So the last one is more confusing. The last one says, if the measure of an angle formed by a tangent and a chord is half the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. This is actually kind of hard to see, so let's kind of talk about it. First of all, an angle formed by a tangent and a chord. So here's a tangent, here's a chord, and the intercepted arc between the tangent and the chord for this one is right here. This one, because the arc and the chords go in the other direction, it's going to be the major angle. Do you see that? So again, when we're talking about these angles that are formed, angles can only be formed with lines, not with circles. So if they're talking about the measure of angle C, they're talking about it from the chord all the way to the angle. So when you're making the angle measurement, or the little line for it, you can actually ignore the circle because it's the whole thing. Same thing here, when you're making this angle, it starts at the chord and it goes all the way to the tangent line. So the chord, the circle part doesn't even matter. So the measure of the angle is half the measure of the intercepted arc, knowing that what that means is if you know the arc, if you know the angle, the arc is going to be double that. So let's look at a problem. So let's look at problem 3A of the Got It problem. So I'm at the bottom of page 783 looking at Got It problem 3A. Okay. Now a couple of reminders. As you look at X in that picture, know that that is from line JL is one of the sides of that angle and the other one is JK. So you can actually kind of ignore the other part. So we're going to start with a couple things. We can start with X. So the first, well, let's start with Y because to me that's a little easier. If you'll notice, actually I'm going to do it on here so I don't have to redraw it. You'll notice that angle J is formed by the outside parts of it are diameter. So that since that's 180, we know that's half. So we know angle actually this one we've got 3 lines, so we'll have to describe it. We know that angle QJL is going to be 90 degrees. So to find Y, if we know that that angle is 90 degrees, then we know this one plus this one is 180 because that's forming a triangle. So we know that 35 degrees plus 90 degrees plus Y equal 180 degrees. So Y has got to be 55 degrees. Sorry about that. Okay. And now we're going to find X. So X is a little bit trickier. So first of all, we know that this angle is half the intercepted arc. So here's the chord and here's the sorry, I probably should scoot over. Here's the chord and here's the tangent line. So if we can get the amount of that, then we can use our formula that we got for a tangent and a chord. So we know this is the intercepted arc of this. So we know that the measure of angle Q is going to be 1/2 the intercepted arc, which is JL. And we know angle Q is 35 degrees. So the measure of JL, so multiply both sides by 2. So we know the measure of JL is going to be 70 degrees. Okay? So if it's 70 degrees, now we can use the formula that we just learned. we know that x, which is the measure of this angle, is going to be 1/2 JL, and obviously, so it's going to be 1/2 of 70 degrees, so x is going to be 35 degrees. So x is 35 degrees, y is 55 degrees. Again, it's always really tight in here looking at these, so you just kind of have to go slow and be careful. Okay, and that's the end of 12.3. Let's move on to 12.4. I'm going to try and get through it in less than 29 minutes so I don't have to make another video. Okay, so now we're going to name some more things. So we've already talked about inscribed angles and what they are, and we've talked about central angles. We have two more angles to learn, and this angle, this angle, this angle, and this angle are called interior angles. So I actually want you to write that above measure of angle 1, write interior angles. Interior angles. So an interior angle is an angle that's formed by two chords. You'll notice it's different than a central angle because a central angle, the vertex has to be in the center of the circle. An interior angle, it can be anywhere. Okay, so that's the formula. Okay, so let's work a problem like that. So I want you to look at problem 1C on page 791. So we're doing got it problem 1C on page 791. And the first thing you have to recognize is that 35 degrees is an interior angle because it's on an interior point of the circle, but it's not in the center. So we're going to use our formula. Our formula says that the measure of an interior angle equal 1/2 intercepted arc 1 plus intercepted arc 2. So we're going to sub in what we know to our formula. We don't know, we know the measure of the interior angle is 35 degrees, equal 1/2. One of the intercepted arcs we don't know, so we're going to put x. The other one is 30 degrees. Okay, so now we just have to solve for x. I'm going to multiply both sides by 2. So I'm going to multiply this by 2 and this by 2. That'll cancel out the 1/2. 70 degrees equal x plus 30 degrees. So x is going to be 40 degrees. So we know that this arc is 40 degrees. Okay? So the next formula, I want you to also write in your book, a lot of writing in your book today. This angle is called an exterior angle. Now, an interior angle is formed by two chords. An exterior angle is formed by two secants. And I think we talked about secants before, but if we haven't, a secant is a line that starts outside of a circle, passes inside the circle, and then outside the circle, and shoots past. It can stop right there, or it can go on. Either way. It's not a tangent because it actually enters and leaves. It doesn't just barely graze the edge. So the formulas, if you have two secants, or if you have a tangent and a secant, or if you have two tangents, rule's going to be the same. The measure of the exterior angle is going to be 1/2 times, I call this the exit arc, and it's easy to remember because they use the letter X, and the entrance arc. So the entrance arc is always going to be smaller than the exit arc. Okay, interesting thing about if it's two tangents, we're not going to do an example like this, but you'll have it in your homework. Even if they only give you one, no, they have to add up to 360. So if this one is x, this one's going to be 360 minus x. So you can use that to help you. Okay, so let's do a problem. Okay, we're going to do, we'll start with, we already did 1C, so we're going to do 1A and then 1B. Got it problem on the bottom of 781. We know that the measure of an exterior angle is going to equal 1/2 times the exit arc minus the entrance arc. Okay, the exterior angle is 70 degrees. The exit arc is W. The entrance arc is 110 degrees. Multiply both sides by 2. Add 110 to both sides. And W is going to be 250 degrees. So you want to kind of see if that makes sense. And it does because it's the whole way around. So it works. This one actually we could have done a little bit easier now that I'm looking at it because the whole thing is 360. We could have just subtracted, but that's all right. It's good practice. Let's do B. We know that the measure of the exterior angle is going to be 1/2 the arc exit minus the arc entrance. So the measure, y is going to be 1/2 times 110 degrees minus 30 degrees. Y is going to be half of 110 minus 30, 80 degrees. Y is going to be 40 degrees. Okay, and that looks about right. Okay, now that's going to be the end of what we're doing with measures. This next part's a little trickier. This next part we're going to actually be looking at segment lengths. So we're not going to be doing anything in degrees because we're not doing how wide or how narrow it is or how much of an arc it is compared to the rest of the circle. We're going to be doing actual segment lengths. So these are two chords. So this situation is with two chords. This situation is with two secants, because remember a secant is one that starts at an exterior angle and passes all the way in. And this one is with a tangent and a secant. Okay, so the rule for two chords, this is the easiest. It's basically a cross product thing. If it's split into two segments, if you multiply those two segments together, it's got to equal the product of the other two segments. This one's trickier. If it's two secants, here's how I remember it, is anything outside the circle counts double. So you're going to multiply the whole length of the secant, which is going to be x plus w, times just the outside part. Same thing for the other secant. You're going to multiply the entire thing times just the outside part. That's what I mean about the outside part kind of counting twice. If it's a tangent and a secant, you're just going to square the tangent and then multiply. The secant is going to work exactly like it did before. It's going to be the whole thing times part of it. Okay, let's try a couple of those. So let's take a look at problem 3A. I went too far. Okay, we'll just do this one down here. Okay, so find the value of the variables in the circle. So I'm on the bottom of page 793, problem 3. Okay, so I recognize that it's a segment, it's two secants. So now that I know it's two secants, it's the whole thing times the outside part equals the whole thing times the outside part. Okay, 6 plus 8 is 14. 14 times 6 is 84. It's going to recopy this for now. And I think it's easier to do the division beforehand. 84 divided by 7 is 12. Those cross out. Equals 7 plus y. Y equals 5. That's all there is to it. So let's take a look at B. So for B, we have a tangent and a secant. So the tangent is going to be squared. The secant is we take the length of the whole thing times the outside part. Okay, and we're doing B. So it's going to be z squared equal the whole thing, which is 16 plus 8 times just the outside part, which is 8. So z squared equal 24 times 8. 24 times 8 is 92. And then we square root the whole thing. It didn't say anything about simple radical form, so we're just going to do it the lowest common denominator. Okay, and that's the end of 12.4. Most students kind of like these two sections. They're pretty straightforward. It is a lot of formulas. You won't be allowed a cheat sheet on chapter 12, so in your head, you want to get in the habit of writing the formulas every time so that you can remember what they are. And that's it for this week. I'll see everybody next week. Bye.